Okay, we should have 3 videos for you guys here today. Might end up being 4. But we're going to be talking about solving systems of equations. So the first thing, what are systems of equations? Well, your systems of equations are the things that are going to look like these up here. Okay, and you have to basically figure out what your x is, what your y is, and it ends up giving you your answer. When you get your answers for these, your answers end up being a point, because you find that x equals, and then you go find that y equals, or you find that y equals, and then you go find what x equals. And there's 3 different ways that we are going to go about solving these systems of equations. One of them is by graphing. The other one is by using substitution. And then the last one is by using elimination. Okay, so that's what we're looking at today. This first one, we're going to just look at the graphs for these. So starting out, they want you to solve the system of equations by graphing. Okay, so here's my systems of equation. X minus 2y equals 0, x plus y equals 6. So I need to solve the systems of equations by graphing. So if I want to graph this here, what do you guys think I need to do first? I hope you're thinking that you need to get it to be y equals 0, because we just went over how we graph those lines in that y equals 0 form. Last part, x plus y equals 6. Okay, what do we need to do first with this one? Well, again, I need to get it so that y equals, or I don't know why I'm saying y equals 0. It does not have to be y equals 0. My bad. It just needs to be in that y equals mx plus b form, okay, so that we can graph that. All right, so first step, first one here, x minus 2y equals 0. I need to get that into my y equals form, so I'm going to subtract x first. Gives me a negative 2y equals a negative x. And then I'm going to divide by negative 2. And when I divide by negative 2, I end up with y equals, remember there's a 1 in front of that there, so negative 1 divided by negative 2 gives me a positive 1/2 x. Okay, so that's my first y equals there. Now, I need to graph this. So we're going to start with the y-intercept. What's the y-intercept of this one here? Well, there is no y-intercept. So remember, if there's no y-intercept, you just add 0 to that. Okay, so it's y equals 1/2 x plus 0. Okay, so I'm going to start here. Okay, and then I'm going to go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. You could also go down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. Okay, so there's my first line that I have. Okay. Next thing we're going to do is we're going to take our next line, x plus y equals 6. Okay, and I'm trying to get y by itself again, so I'm going to subtract x, and when I do that, I get y equals negative x plus 6. So, okay, that one was a lot easier to solve for. Okay, same thing, plot my y-intercept, so my y-intercept is at 6, and then I've got a slope of negative 1 over 1, so I go down 1 to the right 1, 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 and I keep following that pattern. Could have also gone up 1 to the left 1. Okay, and I'm going to draw my line there. Okay, now, the solution to the system is where they intersect. So the solution to the system is where they intersect. So where do the red and blue line intersect? Well, they intersect at this point right here. Now, when you give your solution, you need to give your solution as a point. So our answer is going to be 4, 2. Okay? So what that means is my x equals 4 and my y equals 2. The point 4, 2 is where they are going to intersect. Okay? So, let's go ahead and have you guys pause the video. Okay? Try and do this one on your own here. Solve it by graphing. Okay, so again, our first step when we're trying to solve this, I'm trying to get both of these into a y equals form. Okay, so I need to subtract x. I get 3y equals negative x plus 7. This one's going to be a booger. Divide by 3, divide by 3, divide by 3. Okay? And when I do that, I end up with y equals negative 1/3 x plus 7/3. Okay? And 7/3 is going to be 2 1/3. Okay? Or 2.3 repeating. All right, so that's it for my first one. My last one here, I've got x minus y equals 3. So I need to subtract x. When I do that, I get a negative y equals negative x. I don't know why I wrote that in green, I'm sorry. Negative x plus 3. That y, don't forget that negative there, so I need to divide everything by a negative 1. And when I do that, I get that y equals a positive x minus 3. Okay, now I'm going to start with the blue one here. Okay, y equals x minus 3. Do you guys know why I'm starting with the blue one? It's because that red one looks like it will kind of suck to graph. So I'm going to graph the easier one first. I just went up 1 over 1. That continues. Notice I'm putting a lot of points on these. Putting a lot of points on these because we don't know where these lines are going to intersect. And it should be at an exact point. So I'm trying to find all of these exact points that I can. Okay? Next one, I've got y equals negative 1/3 x plus 7/3. So 7/3 is about 2 1/3. So I'm going to mark a little bit less than a half. Okay? And then my slope is negative 1 to the right 3. So I'm going to go down 1, and then I'm going to go to the right 3 spots. Okay? I'm going to go down 1, and I'm going to go to the right 3 spots. Okay? And I think when you guys do that, you should be able to kind of see where this thing is supposed to intersect at. Okay? So if I'm drawing my line here, it should be intersecting at that point. And some of these are going to be tricky like that. If they're tricky like that, where they have fractions, graph your easier one first. And then after you graph your easier one, graph your more difficult one, and you should be able to see where it's supposed to intersect. So again, our solution, we need to actually write what our solution is. Our solution is 4, 1. So we need to actually write that 4, 1 as a point, okay, so that we know that is what our solution is, okay? So that is graphing your systems of equation. Get them both into y equals form, and then you just graph them both on a graph, and then your solution is where they intersect. Make sure that you label that solution, okay? All right. Don't know what I did there. Now, we just did multiple examples where they were intersecting lines. Okay? However, there are other possibilities. Okay? What we were working on when they were intersecting lines was called consistent and independent systems. Okay? The other possibilities that you could have are, when I'm graphing these lines, you could have a consistent dependent system, which means that they are the same line. Okay? So an example of that would be, say you had 2x plus 4 equals 6, and you had x plus 2y equals 3. These two here are actually the same line. Okay? If I divided everything up here by 2, it would give me x plus 2y equals 3. Okay? So if you get a consistent and dependent system where they are the same line, your solution for that is infinitely many solutions. Okay? So if you get something where they're the same line, you're going to end up getting infinitely many solutions. And we will talk about what that looks like after the elimination. Okay? As far as algebraically what it looks like. If you're graphing it, you're just going to see 2 lines. Or sorry, you're just going to see 1 line. Okay? You just see 1 line because they're the same line. The last one that we're going to talk about is an inconsistent system. And an inconsistent system is your parallel lines. Okay? Now, we talked about with parallel lines, okay, that means that they're not crossing. And our solutions are where they cross. So for this one, we have one solution because that's the one spot that it crosses. For this one, we have infinitely many solutions because these lines are constantly crossing each other. But parallel lines, do parallel lines ever intersect? No. And since parallel lines don't intersect, that means that they will have no solution because they never intersect to offer us one. Okay? So just real quick, practice finding these. Okay? I've got the system of equations below. What type of system of equations is shown? Okay? They went ahead and they graphed both of these for you, and this is what the graph looks like. So it's hit at one point. So if it hits at one point, that means it's got one solution, and that is going to be our consistent and independent system. Our consistent and independent systems are where they cross at one point. Okay? It says graph the systems of equation below. What type of systems is it? Okay, I've got an x plus y equals 3. Sorry, thought I had my eraser on. Got a 2x minus 2y plus 6. Okay? So I've got a 2x plus 2y equals 6. And I'm just showing you guys this is the exact same thing that happened on that last one. Okay? That gives me an x plus y equals 3. These are the same thing. Okay? So since they're the same thing, you guys can tell by their graph, they're a line that is just on top of the other line. They're the exact same line. So your exact same lines are consistent and dependent systems. And the other, probably more important than knowing that they're consistent dependent, those have infinitely many solutions. I probably spelled infinitely wrong. Okay? And then our last example, graph the systems of equations below. What type of system of equations is shown? So I've got a y equals 3x plus 2. I've got a negative 6x plus 2y equals 10. Okay, I can kind of mess with this one a little bit. Add 6. Add 6. That's going to give me a 2y equals, oh, I'm sorry, add 6x. So 2y equals 6x plus 10. Okay, divide by 2, divide by 2, divide by 2. And I end up getting that y equals 3x plus 5. Okay, same slope. Same slope, and I've got a different y-intercept, so that means that those two lines are parallel. When you graph those, you guys would see, yep, they're parallel lines, same slope, they're never going to cross. So since they never cross, that is an example of our inconsistent system. And again, more importantly than knowing that that's your inconsistent system, is knowing that how many solutions does that one have? It has no solutions. Okay, there are no solutions that are offered for that. Okay, and we'll do this on the next video.